So in order to finish school, which I was visiting, for the end we had to do a small electronics project. My school is School of Electrical Engineering and Computer Science in Slovenia, Maribor. And the project had to be something classic like a Bluetooth speaker or a charging battery. And I decided to build a robotic arm. It was pretty challenging. I learned a lot of things on the way. And in this video I will, as efficiently as possible, try to explain how it works and how to put one together if you want. The entire robotic arm is 3D printed and it is pre-programmed to do one specific motion. I used to have a program in which I could control it with 5 buttons, but later I scrapped it and I made it autonomous. So basically it works out of Arduino Mega, which is hidden in here. So in here we can see an Arduino Mega and all the motor drivers. And the good thing about it is it's all powered by an USB 5-volt port, which means theoretically you could power it with a battery bank. So actually it turned out to be a little smaller and a little less complicated than I expected, because the motors are not strong enough to control the entire arm. I wanted to add another section to it which could move up and down, and it would be a lot more complicated and movable, and it could reach more places, but this is how it was. The entire project was finished in about a week. The entire printing lasted for about 12 hours. Here you could see a solution to the motor problem. I basically designed gears and put it on gears so it would have enough power, but the problem is that it's slow, but at least it works right. So in here you could see that it has another set of gears. These gears are really important. This is the heaviest part to lift. It could rotate its head, but the motor inside broke at the last minute. Also, the entire wires on the robotic arm weren't long enough, so I had to solder them and extend them, which was really hard since I had to solder about 30 wires. Here you could also see that we also 3D printed a cup, which the hand is capable of lifting. This is what I show my teachers in school. Of course I got 100% grade for it. Also here we have a rubber band, because the hand is not strong enough to lift by itself. Now we will quickly go through the program.
So now we shall go through the code. Here you can see the LCD display, which I never implemented. And this is just the beginning of code. Keep in mind that the code could be a lot shorter, but I am just a beginner in programming, and I prefer it this way since everything is more visible and you have an exact idea of what you're doing. So here in the first section I defined all the output pins. Originally I wanted to use 6 motors, but like I said, the motors aren't strong enough to lift themselves up, so I only used 4. Here I configured all the pins to output. These used to be buttons, but now there are no more buttons. Here is the entire logical part of the robotic arm, which I shall go through later. Here are basically all the steps. So for one loop, the stepper motor has to go through 8 steps. So this is the basics of how the stepper motor works. It's basically like binary: low, 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 high, low, low, high, high, and it goes through. So for each motor you have to have this line of code for one direction and another one for the other direction. So for 4 motors I have to have 8 steps. And each step is numbered and named, so I have an exact idea of what it does. For example, step 1, this is stepper motor 1. Counter step 1, this is stepper motor 1 but goes in the other direction if I use it. Stepper motor 2, counter stepper motor 2, stepper motor 3, and so on. Understanding of this will allow us to understand this code. So this is the entire autonomous part. So basically we have a few variables, z and x. X represents for how many degrees the motor will rotate, for example, roughly 20 degrees, let's say. And this is the first step, so z equals 0, it starts with 0. It asks if z is 0, if z is 0 it starts the program. Then it starts counter-rotating stepper motor 4, which means the base of the robotic arm rotates. So after it's done that 2000 times, if x is 2000, then it resets the x to 0 and counts one more to z, or z, however you prefer. So then z equals 1 and it goes on to the step, which is step 3. Here it lifts up the arm for 10 degrees, and then after it's done doing that, it goes here and it grabs the cup, and then it moves it to the right, and then it puts it down, and so on, and it goes back to its original position, and it starts all over again. Yes.
And the robotic arm also has some small personal details which I added. For example, on the side, if you look at it, it says 2018 and Mark 1, which means this is a generation 1 which I designed. Here it says my name. Oh, in a case if you're downloading and printing the arm, yeah, it will have my name on it. You can remove that if you know how to use programs for designing 3D sculptures. And also on the other side it says Matura, which is basically the subject which I had to design the robotic arm for. Basically the final exam.
So this is basically it. The entire thing explained. I will leave the entire code down in the description and also a 3D model of the code. I would like to thank everybody who works on Arduino projects and uploads them to YouTube, since without them I wouldn't understand anything and I couldn't complete my school project. Open source is always appreciated, is basically why I did this video. If anyone wants to get into coding or programming a small robotic Arduino arm, they can just simply pick up this video and maybe learn something from it. Thank you for your time. I hope I will see you on my next project.
God damn it.